The proposed MMREC framework leverages large language models, LLMs, and deep learning techniques to enhance the accuracy and relevance of recommendations in a multimodal recommender system. This novel approach aims to better understand and utilize natural language data, addressing the limitations of previous methods. The framework efficiently extracts and integrates text and image information through LLMs, unifying diverse modalities in a latent space to simplify the learning process for the ranking model. Experimental results demonstrate the enhanced discriminative power of the model when utilizing multimodal information, particularly in improving the false positive rate in the case of imbalanced datasets. The paper begins by discussing the evolution of recommender systems, RS, from collaborative filtering techniques to the integration of machine learning and deep learning. It highlights the importance of leveraging collective insights from a large user base and the role of vector representations in memory-based and model-based CF approaches. The paper also touches on the application of graph neural networks, such as CNN, GCN, and GraphSage, which have significantly enhanced model-based CF methods. In terms of LLMs, the paper reviews recent efforts in utilizing these models for RS. It mentions the use of LLMs as interfaces for RS, enhancing interactivity and explainability. A three-step prompting strategy is discussed, which surpasses traditional simple prompting techniques in zero-shot settings. The paper also references the use of an instructor module to pre-process users' instructions and traditional feedback, generating tailored guidance. The dataset used in this study is a comprehensive dataset tailored for restaurant reviews analysis, collected from Google reviews and published on Kaggle. The dataset includes both text and image data, providing a rich source of multimodal information for the proposed MMREC framework. The proposed MMREC model is a multimodal recommender system that leverages the capabilities of large language models, LLMs, to enhance feature engineering in a deep learning recommendation model, DLRM. This approach aims to improve the performance of the recommendation task by utilizing LLMs for summarization and contextual understanding of user reviews and images. The dataset used in this study comprises user-generated reviews for various restaurants, including unique user IDs, business IDs, review ratings, and associated images. The methodology involves several key steps. First, the textual information contained in user reviews is converted into embeddings using a sentence transformer, specifically the Mini-LML6 version 2 model. Similarly, images are transformed into continuous data using ResNet50. To leverage the summarizing power of LLMs, the model extracts pricing information from user reviews and summarizes the most important information from all textual and visual reviews. This approach reduces noise, unifies the embedding technique for different modalities, and introduces an additional sparse feature for categorizing each restaurant into one of 11 categories. The model also employs dimensionality reduction techniques to mitigate the risk of overfitting caused by high-dimensional outputs. This involves concatenating the embeddings from both the text and image encoders, feeding this combined tensor through a multi-layer perceptron, MLP, and applying the same MLP during the testing phase to ensure effective dimensionality reduction while retaining crucial information for prediction. The experiment section of the paper discusses various parameters and configurations used to evaluate the model's performance under different conditions. These include experimenting with various dropout rates, weighted loss functions, and baseline versus proposed models. The dataset is highly imbalanced, with only 1/8 of the data points associated with false labels, and the rest being positive samples. To balance the impact of each class on the loss function, the authors experiment with different weighted loss functions, calculating weights using specific formulas. The proposed multimodal recommender system, MMREC, leverages a large language model, LLM, to enhance the deep learning recommendation model, DLRM, for restaurant recommendations. This system utilizes dense features such as the number of reviews, average user and business ratings, and sparse features like restaurant categories. Additionally, it incorporates embedding features generated with the help of LLM and multimodal models, including user-reviewed text, business-reviewed text, and review image features. The performance of the proposed model is evaluated against both training and testing sets, demonstrating improved accuracy and reduced false positive rates compared to the baseline model. The addition of new dense features, such as price tags, and sparse features, like restaurant categories, contributes to these improvements. These features are generated using prompt engineering with the GPT 3.5 Turbo 1106 model, allowing for more nuanced understanding of user preferences and business characteristics. The price tag feature categorizes restaurants into fair price, overpriced, cheap price, or none based on reviews, while the restaurant category feature generates a list of subtypes for each restaurant, with a maximum of 11 subtypes. The embedding features are also enhanced by summarizing all reviews written by the same user and all reviews received by the business using LLM, which significantly improves the model's performance. The results indicate that the proposed model outperforms the baseline model in terms of accuracy and false positive rate, suggesting that incorporating LLM based features can effectively enhance recommendation systems. However, the model still has limitations, such as requiring a large amount of data for training and potential biases in the generated features. Future work could involve addressing these issues and further refining the model to improve its performance and applicability. In the realm of deep learning-based recommender systems, the proposed model, MMREC, leverages the capabilities of large language models, LLMs, to process multimodal information effectively. This innovative framework integrates textual and visual data into a unified latent space, enhancing the performance of the model. The utilization of LLMs allows for the summarization of user reviews and the generation of textual information from images, providing a more comprehensive input for the model. This approach significantly reduces the false positive rate in the model, particularly due to the ability to extract valuable insights from negative reviews and the summarization capabilities of LLMs. The proposed model outperforms the baseline model in terms of false positive rate, both in the train and test sets, with the best model achieving a false positive rate of around 2%. The model with the highest accuracy, however, is the baseline model with a 0.5 dropout rate in square root weight, achieving 93.47% accuracy with a 37.58% false positive rate against the test set. The proposed model also exhibits a clear overfitting with a lower dropout rate, resulting in increased accuracy and a reduced false positive rate. The paper concludes that the integration of multimodal data and the utilization of LLMs can enhance the performance of deep learning-based recommender systems, especially in scenarios involving imbalanced datasets. This research paper presents a comprehensive review of existing literature on recommender systems, focusing on the integration of large language models, LLMs, and multimodal data. The authors provide an extensive list of references, covering various aspects of recommender systems, including deep learning-based methods, graph convolutional networks, and knowledge-enhanced prompt learning. The paper highlights the importance of incorporating multiple modalities, such as text, images, and user behavior, to improve the accuracy and diversity of recommendations. The authors discuss the challenges of processing and integrating these modalities, including the need for effective feature extraction and fusion techniques. Several studies are cited that demonstrate the effectiveness of LLMs in recommender systems, including their ability to capture complex user preferences and generate personalized recommendations. The paper also discusses the potential of LLMs to enhance the interpretability and transparency of recommender systems, by providing insights into the decision-making process. The authors also review various techniques for incorporating knowledge graphs and external knowledge sources into recommender systems, including graph-based methods and knowledge-enhanced prompt learning. These techniques are shown to improve the accuracy and diversity of recommendations, by leveraging the rich semantic information contained in knowledge graphs. The paper concludes by highlighting the limitations and future directions of existing research, including the need for more effective methods for integrating multiple modalities and knowledge sources, and the importance of addressing issues related to fairness, transparency, and explainability in recommender systems. Key concepts and methodologies discussed in the paper include large language models, LLMs, and their applications in recommender systems, multimodal data integration and fusion techniques, graph convolutional networks and knowledge-enhanced prompt learning, knowledge graphs and external knowledge sources, deep learning-based methods for recommender systems. Interpretability and transparency in recommender systems. The paper provides a comprehensive overview of the current state of research in recommender systems, highlighting the potential of LLMs and multimodal data integration to improve the accuracy and diversity of recommendations.